Another type of pattern is peripheral flooding pattern. Now in this case, the injector well is situated only in the periphery of the field. For example, this is a field. These triangles are injector well and these circles are producing wells. As you can see, this is the extent of the field and the injector wells are placed only on the outer boundary. So in most of the cases, what usually happens is the number of injector well is less than the number of producing wells. And also, if you want to visualize this, the spacing between these wells is in terms of acres. Let us say this region will be around of 10 to 20 acres. So you can understand the time taken for water to reach from this place to this place. This small square block will represent around 10 to 25 acres. So the field is extremely large and it definitely requires a large amount of water. Moreover, the number of injector wells are comparatively lesser than the producing wells. So first of all, you will obtain delayed response. Because a large amount of time will be taken to fill up the reservoir first. The fill up process will start first because you have completed the primary recovery. And after primary recovery, there's a empty space which is filled by the hydrocarbon gas. And during the fill up process, your water will fill up those empty voids in the reservoir. It will compress the remaining gas into a smaller portion. And so you can say that delay in fill up, if the fill up is delayed, then the response will also be delayed. And response basically increase in flow rate will be after a long period of time. And to deal with this situation, what you can do that after a certain point of time, these wells will start producing water, but the inner wells will still produce the oil. What is happening in this case is that there was some oil bank. This was your oil bank. Now the water is being injected and it is basically compressing or squeezing your oil bank into the inner wells. So after some point of time, oil bank will recede to this point. So these wells will largely produce water. So what we can do is that we can convert these producing wells to injector wells for more efficient displacement. So they will push and squeeze your oil bank from the central producing wells. So this is the peripheral pattern. Now there's one more thing, that in such type of patterns, let me draw another picture. Yeah, before that I would like to mention that it is one of the efficient flooding pattern. Efficient as in you can obtain maximum oil recovery with minimum water production. That is, the water production will be minimum in this case. That is one of the advantage of using peripheral flooding. Now, for example, let us compare that case with this case. You can see that the number of injector wells are quite high in this case, right? And therefore, the input was less in this case. वाटर का इनपुट कम है, पेरिफेरल में बस थोड़े बहुत वेल हैं, बट दे आर a large number of injector wells, so input of water is very high in this case. Now if let us take a case that in some reservoir it is having 35% of the recovery, and same result is obtained from this as well. Recovery factors is 35% in this case, but the water oil ratio will be extremely less when we compare it this one. So high water production is also one of the major disadvantage, because you have to separate out oil with against water. You have to separate out oil from the water, and you have to process this water again. So this requires additional facilities for processing, and therefore the cost will be higher if water displacement is or water oil ratio is high. So this is the advantage of peripheral recovery, that the input of water is less and it is squeezing out oil, so therefore you will have minimum water production. Now one of the major disadvantage of using peripheral recovery is that you do not have a good control on your field, on the process, on the system. Our control is not very good. Now we can say that this is a large field and some of the injector wells are in the periphery, while there are producer wells, bunch of producer wells in the central region. So you can only control the mobility of the reservoir in this specific region only. You have displaced the water from this region, इसके बाद पानी जो गया, you cannot have control beyond this region. So very limited region can be controlled, hence this system is not under control. But in case of regular pattern, the density of injector wells can be increased, and hence you can control the injection, mobility and sweep efficiency, all those things in these regions as well. So larger the number of injector wells, better the control, better the efficiency you can have. So that is why we use regular injection pattern.